but and we'll do some discussion. I'm going to throw some more ideas at you. So I want to leave you with a real breadth of interesting ideas. These are real teacher ones. About to go into a school in Oxford and do this one in a single PE lesson. That's a prediction on the right there. It's not actual evidence, so don't go thinking this works. But if you're a PE teacher, anyone a PE teacher? Teach GCSE PE? Positive visualisation improving performance is in the PE curriculum. Now we know from professional golfer research that if you get them to putt over 8 feet, they imagine going in the hole compared to missing, they get more in the hole. But is that really transferable to children? That's professional golf. So this is going to be one single PE lesson in which we randomly allocate the children to throwing basketballs. Then we're going to randomly allocate them to having a positive or sensory visualisation. But then actually we're going to use a negative visualisation for one group, because if it's actually visualising the positive, then if it's the negative, it should go the other way. We can critique that one. I tell you what, I'm still debating that design with Ellie at the moment, actually, but because we're going to pass on some. But that's what the school wants to do, and I think it's a jolly interesting one. These are all going to be on the website, pluses and minuses of designs. There is no, but I want you to leave with the thought that there is no single right design. So between subject design, like we did at the start, is right when you can't unlearn the effects. I had to debrief to those people what this was from. That's going to influence the other group, isn't it? So they can't unlearn that effect. If they do that again, they'll always associate it with hypnosis, won't they? So they're never going to unlearn that. So I can't use it within subject design. But you do need big samples sometimes, unless you can do some other clever things. Within subject designs, again, have advantages and disadvantages. People can get fed up if they've got to repeat something. You've got to make sure it's separated in some way, and you need to counterbalance. The one other design that is commonly used in psychology that's worth thinking about is actually to match pair people. So if you're stuck with a situation where you can't unlearn the effects, what we could do is I could pair you up. So I could have a look around the room and I could think, okay, men with glasses in the age range 21, etc., etc., women wearing pink. But characteristics that might influence the research, for example. And then once I've got you in a pair, you guys, I then randomly allocate you to control intervention. I have to use some different maths to look at the data. So that's going to help me to deal with that issue there. But I still randomly allocate you within each pair. What I want to talk about finally today is the importance of the statistics. That was a really interesting journey. Oh, and firstly, things that teachers have done. And I want you to use the analogy of a beehive. The interesting journey I travelled when I started, it was a very different world to enter. And most of the research studies I was reading actually had quite small samples with very tightly controlled designs. And actually, in many cases, they haven't got 100 people together. In some cases, they've done it one person at a time. So if you take hypnosis, we know that people who are high hypnotisables, when they're hypnotised, they do better on a test called the Stroop test, for example. You can do that one person at a time on a computer. But if you keep your protocol the same, you can scale it up. So one of the things that schools are looking at, particularly, and I'll share some of these ones with you, is this idea of keeping your control group and intervention group cells similar. So supposing I was going to travel around to different places around the country and do that same introduction to a talk, and I knew I was going to be in a theatre, and I knew I had 2 people to help me, and I repeat it in the same way, arguably, because control and intervention took place in the same context with all those variables similar, I can just stack them up to build my sample size. Or even in the teaching schools, we begin to do this, to think about one cell being in one school, one cell in another school. Because control and intervention in 2 different places, arguably, it's all nicely balanced. Or even you could be like the scientists of the 19th century, the great observers like Darwin, who spent a lifetime collecting enough data to be able to be certain in a linear way. So maybe you've got something you really want to research, and you know it can only take place in the first month of every September with the Year 7s in that procedure of work, then do it 4 years running with 2 classes, and take the long view on your data. Well, of course, teachers are different, aren't they? So one teacher said, this came up at an event the other week, what a great idea. Well, not just randomly allocate the children, so they had a 4-lesson design to do with group work versus textbook work and learning of information and topic on geography. It was Rivers, actually. And So it was going to be over 4 lessons, and the teachers were blocked at the same time, so that was a problem, because the teachers are different characters, aren't they? Teacher variation. So they came up with the idea, I don't know if they've done it yet on the next network event, randomly allocating the teachers to the order in which they teach a lesson scheme work, and trusting them to maintain the protocol during the lesson. So there's been a balance of teacher to control. And B's use existing structures. So we're doing a trial, we're going to start a trial with a cluster of nursery schools coming up very shortly. And in that design, we were debating it with Everton School up in the north of England. And we're talking about how on earth we're going to deal with the randomisation thing with nursery school children. The achievement thing's not difficult, we just have an observational scale like this there, so we're going to observe them at the school. We don't have to do the test, we do that. But it turned out that many primaries and nursery schools are already stratifying their sample on entry to school. So they're making sure there's a balance of gender, ethnicity, SEN and attainment. So they'd already created, not quite matched pair, but enough of a balance that they could simply randomly allocate class to control or intervention at that level of economy. And blind trials are an opportunity in education. One teacher at an event said last week, actually this week, said, you know what, I'm beginning to realise that this second networking event where we're doing more of this, said, I'm beginning to realise I'm giving blind trials all the time. I don't tell them I've been on a course, but I experiment with it. Actually, I could carry on that experiment, they don't even need to know. And I remove all those issues I have in the laboratory, and I'm perfectly allowed to try things out and give people tests. I've just been doing it without a structure. And I think that's a really interesting observation. And you may like to think about having a blind test. Anna, you knew nothing about what that was about, did you? All I did was brief you to score people, so there was no influence there. So that's particularly helpful, I think, in English, where you might be looking at something more complicated, dependent variable, like the comprehension skill. So someone trained in the GCSE criteria could mark it, but don't know what it is you could do. Have a blind tester, perhaps. And these have specialist roles. People like a chap here, in a cluster of schools or a local schools as psychologists, they are assets because they can tell you what tests to use and they can teach you things as well. A lot you can do in Excel like we did, etc. But I'm going to say something quickly that I do want to add in before questions, which is there is a proper way to go through statistical analysis. And we didn't do it then because we didn't have time. We took a guess. And I took that guess based on what I observed, and I made the right guess, I think. But you're supposed to look at the distribution. Draw a histogram and have a look to see if it looks like a bell curve. And I'm going to tell you why in a minute. Because then you should use the right test for that. Don't just apply an effect size and assume you've got an answer. It's incorrect. You can miss something. So why is that? Well, we need a story for that, which is the story of the poison atropine. Atropine is a very deadly poison, deadly nightshade. It's used by women for centuries to make their eyes look bigger because it dilates the pupil and makes them look more sexually attractive. But in quantities, it's absolutely deadly poisonous. Now, a doctor called Thomas Frazier came across someone who had been poisoned with atropine, belladonna, and he made a link through his biological understanding. He made auxiliary rap. He saw someone poisoned by anthrax and noticed that he was really constricted and tight. And he knew about belladonna, so he gave them the poison. And the poison fixed them. One deadly poison was an antidote for another deadly poison. In fact, it's later been discovered that it's also, it can cure poisoning with sarin gas. Why is this important? Well, teacher practitioner research, again. A local teacher practitioner finding. Your local doctor may well be doing a randomised control trial around treatments and costs. They do them at their local level, and then they share those findings. The question here is about diagnosis and the way some substances can be poisonous. You don't know that unless you look at the data carefully. So here's the point. In fact, that all substances are poisonous. Water is a poison in large quantities. In fact, Botox, a teaspoon of that, would wipe out everybody in Birmingham virtually. And yet the tiniest bit is a wonder cure I'm going to go out on a limb here, I think that's been our problem. So take phonics, for example. We find great evidence for phonics, perhaps with children who got to school and need acceleration. But I think, as Andrew Davis pointed out, you give it to people who can already read, and he described it as child abuse, I think, quite recently. Interesting thought. Maybe we're not doing the data right. And here's what I want to point out to you. Who knows about the effect size calculation that's been talked about a lot today? Yeah? You take the treatment mean, that's that D treatment mean, you take away the control group mean, and you divide it by the pooled standard deviation. Forget the mass, that's just the spread of people. How wide was the spread? So if you look at my distributions here, I've got a wide spread there, and then over there I've got two half as wide spreads. Now, if I didn't draw a histogram and look at that data and calculate Cohen's D, that looks like a 0.62 effect size. I go, whoa, a large effect size, a gain of 6 months. I'm not quite sure how that affects, quite works like that. Certainly in the hypnosis one we just did, I couldn't see that. In fact, what's happening is whatever treatment this is poisonous to one group. One subgroup has gone down. In fact, if you calculate Cohen's D from the midpoint, for each of those, you find it's a very large effect size in both directions. And we missed it because we didn't look at the distribution first. So I would just say to you, by all means, calculate Cohen's D. You can do a P level for probability using a t-test in Excel. Not necessarily the right test, but it's a lot closer and it won't be that far off. But get someone in year 9 or a smart cleared in year 6 to draw a histogram for you and just check there isn't something else going on with subgroup, because you leap up on one of these conferences and says, I found a 0.6 effect size, everyone should experience it. How does that translate into medicine? We know that very well, don't we? We don't give chemotherapy to everyone just because some people get it. It's a wonder cure for some, but it would be disastrous if it was given to all healthy people. So I hope that was some challenging and interesting ideas. I've gone through it fairly quickly. If you want to ask, if you've got some questions, let's fire away. I'm not sure quite how long we've got.